Now we will see the main features of the quantum mechanical model of atom. The first one, the energy of the electrons in atom is quantized. So already you discussed what is the energy of the atom is here quantized. What the quantized means? It has definite value. The second one, the existence of quantized electronic energy levels is the direct result of the wavelength property of electron. The solutions of Schrödinger wave equation give the allowed energy levels. That means orbital. So we know that already discussed that we are introduced wave function. What is the wave function? Wave function is a function of position of coordinates of the particle. Or particle in the axis coordinate in the position இருக்குன்னு சொன்னது யாருனாக்கா wave function. So based on the wave function, the Schrödinger introduced the allowed energy level. So electron எனக்கு எங்க இருக்கும்? அப்ப electron இருக்கிற place தான் சொல்ல போறோம் orbits. Next, according to the Heisenberg uncertainty principle, the exact position and moment of an electron cannot be determined with absolute accuracy. As a consequence, the quantum mechanics introduce the concepts of orbit. The orbital is a three-dimensional space in which the probability of finding the electron is maximum. அப்போ according to the Heisenberg principle நம்மளால கண்டிப்பா simultaneously அது position and moment னால calculate பண்ண முடியாது. But the quantum mechanics is a full field. He introduced the concept of orbit. Orbit சொல்றது what is orbit? Orbit is nothing but the orbit is a three-dimensional space in which the probability of finding the electron is maximum. So ஒரு atomல எங்க வந்து எனக்கு வந்து எலக்ட்ரான்ஸ் வந்து எனக்கு அதிகமாக இருக்கும் the probability of finding electrons maximum எங்க வந்து எனக்கு எலக்ட்ரான் டென்சிட்டி அதிகமாக இருக்குமோ that space is called as orbital is a three-dimensional space. Next, fourth one, the solution of Schrödinger wave equation for the allowed energy levels of an atom gives the wave function psi, which references a atomic orbital. That the wave nature of the electron present in an orbit can be well defined by the wave function. இப்போ தான் பார்த்தோம் இல்லையா கான்ஸ்டன்ட் ஈக்குவேஷன் வந்து எதை வந்தாக்கா அது allowed energy level. The allowed energy level nothing but atomic orbital. So the atomic orbital can be introduced by a wave function psi. அப்போ இங்க psi ஒண்ணுமே இல்ல அந்த ஆட்டமுடைய ஆர்பிட்டால் என்ன சொல்ல போறேன் psi. The fifth one, the wave function psi itself no physical meaning. However, the probability of finding electron is small volume dx, dy, dz around the point x, y, z is directly proportional to the modulus square of psi of x, y, z dx, dy, dz is known as the probability of density and always particle. Probability and density and always particle. என்ன சொல்றாங்க wave function க்கு there is any physical meaning. அது எதை வச்சு நம்ம டிட்டர்மைன் பண்ண physical meaning னாக்கா அதுக்கு ஒரு definite value கிடையாது. So எந்த ஒரு நியூமரிக்கல் வேல்யூவும் கிடையாது. அது எதை வச்சு நம்ம டிஃபைன் பண்ணலாம்னாக்கா the probability of finding electron. ஸோ எங்கே வந்து எனக்கு probability of finding electron probability means you have to மேபின்னு தான் சொல்லுவோம் பாசிபிலிட்டிஸ்னாக்கா கண்டிப்பாக. ஸோ probability means ஸோ you have to maybe இப்போ எலக்ட்ரான் எங்கெல்லாம் இருக்குமோ அந்த டென்சிட்டி என்ன சொல்ல போகிறேன் சைன் சொல்ல போகிறேன். the psi value always will be a positive. So what about the around the nucleus, what about the value for the modulus square of psi of x, y, z. So that's all about the main features of quantum mechanical model of the atom. The first one, the electron will be quantized. Second one, based on the Schrödinger, it given the allowed energy level. Third one, according to uncertainty principle, we can't predict position and momentum, but based on the quantum mechanics, he introduced a concept that is called orbital. So based on the orbital, you can find what about the electron, what about the position of the electron, what about the moment of the electron. The orbital is a three-dimensional space in which the probability of finding electron is the maximum. Next is the Schrödinger equation gives the wave function. What is the wave function? Nothing but atomic orbital. So எனக்கு எங்கெல்லாம் எலக்ட்ரான் இருக்குமோ அதை தான் சொல்ல போறேன் atomic orbital சொல்ல போறேன். இந்த atomic orbital denoted by a wave function psi. So the psiக்கு வந்து பார்த்தாக்கா there's any physical meaning. அந்த psiக்கு எந்த ஒரு physical meaning இருக்காது. பட் அதை எதை வச்சு நம்ம டிட்டர்மைன் பண்ணாக்கா the probability of finding electron. The probability of finding electron density and it is always positive. The value is modulus square of psi of x, y, z. So that's about the main features of quantum mechanical model of the atom.
Schrödinger wave equation. The quantum mechanical model of atom was developed by Erwin Schrödinger in 1926. The base for the wave mechanical model, that is, electron has particle as well as wave nature, is wave equation. The wave equation describes that the electron in motion as a three-dimensional wave traveling in the electric field of positive nucleus. The wave motion of electron given by the wave equation. See the wave equation below. This equation is called Schrödinger differential wave equation, where x, y, z are Cartesian coordinates of electron. M is equal to mass of electron, h is equal to Planck's constant, E is equal to total energy of electron, kinetic energy plus potential energy. V is equal to potential energy of electron, Pe. Psi is equal to wave function of electron. Therefore, wave equation is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into E minus V psi is equal to 0. Significance of psi. Psi is a wave function. It gives the amplitude of electron wave or intensity of wave, expressed in terms of x, y, z. It may be positive or negative value, depends upon the value of coordinates. As the electric field strength increases, the value of psi increases and reaches maximum and then decreases. Eigenwave function psi. The acceptable solution of the wave equation are called eigenwave functions, denoted by psi. In eigenwave function, psi must be continuous, psi must be finite, and psi must be single-valued at any point. The probability of finding electron must be equal to 1. Significance of psi square. It is probability of function. It indicates the probability of finding an electron in the space around the nucleus. The probability of finding electron is maximum at max psi square value, that is 95%. It leads to the idea of atomic orbital. Probability distributions. The complete probability distribution of electron can be done in two ways. 1. Radial probability distribution. 2. Angular probability distribution. Radial probability distribution, or the function. Definition. The probability of locating the electron at different distances from the nucleus within a small radial space is given by radial probability distribution curve. The radial probability d is equal to 4 pi square dr psi square, where r distance from the nucleus to shell, radius, dr thickness of shell, 4 pi r square dr volume of spherical shell between r and r plus dr. D function. The radial distribution curves obtained by plotting the function of 4 pi r square psi square against the distance r from the nucleus. Angular probability distribution of orbital or shapes of orbitals. Definition. The probability of locating an electron in a particular direction is given by angular probability distribution curves. The angular probability of electron depends only on direction. From this curve, probability of electron is 0 at origin, that is, electron is at nucleus. The peak gives the distance from the nucleus where the probability of electron is maximum. The probability distribution vary according to principal quantum number n. From this graph, probability of finding electron maximum at distance r0 is equal to 05.41 angstrom, which is radius of first orbit given by Bohr. At 0, probability of E minus is 0, that is, at nucleus. This is for 1s orbital. It has only one peak.
Atom is the basic unit of matter that retains all of the chemical properties of an element. Atoms combine to form molecules, which then interact to form solids, gases, or liquids. For example, water is composed of hydrogen and oxygen, atoms that have combined to form water molecules. The term atom comes from the Greek word for indivisible, because it was once thought that atoms were the smallest things in the universe and could not be divided. Now, we know that atoms are made up of three particles: protons, neutrons and electrons, which are composed of even smaller particles. Matter is composed of indivisible building blocks. This idea was first recorded as early as the 5th century BCE with Leucippus and Democritus. The Greeks called these particles atomos, meaning indivisible, and the modern word atom is derived from this term. Democritus proposed that different types and combinations of these particles were responsible for the various forms of matter. However, these ideas were largely ignored at the time. The concept of the atom was revisited and elaborated upon by many scientists and philosophers. However, the English chemist and meteorologist John Dalton is credited with the first modern atomic theory. In the early 1800s, introduced a more modern concept of atoms. He noticed that atoms always combine together as whole numbers to form molecules and compounds and not as a fraction or a decimal number. He named this observation the atomic theory. After few years later, in 1897, J. Thomson was the first scientist to discover a subatomic particle, the corpuscle, which was later named the electron. In 1911, Ernest Rutherford developed the nuclear model of the atom. In this model, he explained that the majority of the atom's mass is concentrated at the center of the atom, holding positive charge, while the electrons float around it in well-defined circular orbits. He called the positively charged center nucleus. He explained that the space between the nucleus and the electrons were huge in proportion to their size. Just 2 years later, in 1913, this drawback of Rutherford's atomic model was enlightened by Niels Bohr. This was the greatest achievement in the journey of understanding atoms. He proposed that the electrons in an atom existed only in specific discrete orbits, or shells, and no electron could exist outside these shells. This model was also compared to the solar system. Also, he declared that the different shells were unique with fixed energy levels. The first shell had less energy than the shells further from the nucleus. He observed that the electrons existing in each shell also had fixed energy. When an electron of a specific cell absorbs more energy, it jumps to the next higher shell, and when the electron loses its energy, it falls back to the previous shell. He also introduced the theory that each shell could hold a specific number of electrons. This was explained by naming the shells alphabetically, from K, L, M, N, and so on. Each shell was subscripted with a periodic number from the nucleus, as n equals 1, n equals 2, and so on. He provided the formula 2n2 to determine the number of electrons in each shell. For example, in the first shell Kn equals 1, the number of electrons would be 2x12 equals 2. And, in the second shell Kn equals 2, the number of electrons would be 2x22 equals 2x4 equals 8. So, he concluded that the electrons revolved around a positively charged nucleus in fixed orbits. Even though the Bohr's model was widely accepted and formed the base of several scientific innovations. In 1926, Erwin Schrödinger, an Austrian physicist, upgraded it and founded the quantum mechanical model of the atom. He observed that the electrons were not particles, but waves. He did this by mathematically stating that the possibility of finding an electron at a specific position inside the atom was uncertain. So, it must act like waves. Till 1932, it was believed that the atom consists of a nucleus with electrons surrounding it. But Sir James Chadwick performed an experiment by bombarding beryllium atoms with alpha particles. This experiment produced radiation consisting of unknown particles, having a neutral charge and mass almost similar to protons. This particle was named neutron. The discovery of neutron paved the way to the development of many successful scientific inventions, including the atom bomb.